coming back from possibly one of my most favorite places on earth, the scrapyard, I've got some pretty sweet building material. With this 6x6 material, we're going to build some heavy support brackets. First, on the deck of the truck, I'm just going to draw out roughly what we're going to be building, so we got a rough idea of what we're going to do. It seems the previous owners of this 6x6 were in a little bit of a haste to get rid of it, so it's got some jagged edges on the end of it. Today, we're not going to be using a torch like the last person did. We're going to go really simple, because this is only 1/8 inch steel. We're actually going to be using the zip disc to cut all of this. After I'm done rolling the square around all of the 4 corners and marking it, I'm actually going to mark the cut lines for the 45 degrees. Now the paint pen that I'm using leaves a mark probably about 1/8 of an inch wide, and coincidentally, the zip discs that I'm going to be cutting with later are going to be 1/8 of an inch wide as well. So I'm just factoring that little bit extra in on all my measurements so that I can take that material away later when I cut it. The key here with all of that is I'm going to have to make sure that the zip disc cutting is all bang on and I don't kind of cut to one side or the other. However, in all honesty though, I mean, unless it's on the top square part, which will be exposed to being seen, if I make some small errors, it's actually okay because later on I'm going to weld this and I'll do quite a bit of filling in there. Now let's grab some of the safety gear and throw it on and get started on this whole thing. Now I know what you're saying, I don't have long sleeves and I don't have a guard on the grinder, but these are the choices that I make, and if you're going to cut and grind, you make the choices that are safe for you. One thing that I definitely do recommend is whatever brand you choose for your zip discs, make sure it's a good quality brand. I've pretty much figured out recently that buying the cheap ones pretty much disintegrate and create so much dust that it's just not worth having them around. Now, let's throw this in the recycling bin and get started on cutting the rest of this apart. So now that I've taken the time to cut the first one out here, let's get this thing off of here and compare it to the other ones and make sure that all my layouts are pretty darn close. Looks like it did pretty good here. Now let's cut the rest of these out and lay them out on the deck. And now that I've got them all cut out, I'm just going to check to make sure that they're all the right size. And then I'm going to calculate how long that bottom bar is going to be. Perhaps me measuring the top part and checking my work here isn't very helpful for you. It's actually the angle open part that I cut. I needed to calculate how long that was going to be to calculate how long my plate is. And now that I have that measurement, I'm going to sit down at the computer and we're going to program this all out on Vectric Expire. Now, Vectric isn't exactly the perfect program to use for CNC cutting, but it's the one that I have, and it's the one that I found success with on a lot of kind of multi-purpose stuff. One of the drawbacks is I'm going to have to go into the G code, but it's actually not as hard as you might think. Now, this program's pretty basic here, especially for this. I've got my box drawn out, and then I'm just going to make some round corners on the end of the plate. And then I'm going to go into my, I think it's the vectors, and I'm just going to grab that little dot here in the middle here, and I'm actually going to pull it down a little bit. Because, I mean, these are going to be decorative for the outside of someone's house, and I don't want it to be kind of boring. The cool part about this program here is it can do all of the 2.5 dimensional stuff that you want, or even single dimension stuff like this, and it's pretty easy to use, and there's a ton of videos on the internet to kind of get you up to speed on how to use it. So now that I've got it pretty much how I want it here on the computer here, we're just going to slide it over a little bit, and maybe we'll change that bottom part just a little bit more just to pronunciate it so you can see it from the street. And now we're going to have to export it to G code, and up on my right hand side here, that's the tab that I'm going to use, and I'm just going to cut on the outside of the line here. And I'm just going to go through that little toolbar there and basically just check off all the stuff that I need. I'm also going to create a little bit of a lead in. The lead in is going to be super important because it's going to make a big hole where I start cutting, and I don't want it to be on the actual line where we're cutting. So with this program as well, you can also kind of run a dry run of what you're actually going to have and just kind of click and run through. That's where the yellow page is going to pop up here in a second. And although be it says I'm using a torch in this, it's actually in the computer program thinks it's using an end mill. Basically, I've just figured out how wide the kerf is on the torch, and I've just made the end mill size that size in the programming. Now I'm going to export this here, and then I'm going to open it up in a read document in Windows. You can pretty much open the G-code in whatever you want, and the only thing that I have to do here is add an M01 code. Now, M01 is going to be a pause, and then I just have to hit start, and then the program will continue. This is important to me because I need to pause it to do my preheat before we start cutting with the torch. And speaking of that, let's simply save this to the USB stick, and then we're going to run out to the shop, we're going to hook up the torches, and get this thing rolling along. And tip of the day, if you don't use torches very often, remember every time to turn off your torches, you should always wind that knob out, relieving the pressure. That way, when you turn the gas on, it doesn't bump your gauges and ruin your gauges. And speaking of saving gauges from being ruined, I've also installed some flashback arresters and some quick connects from the last video that I had. And lucky for me, we're going to use the plate that's been hanging out behind my milling machine because coming up in April, we're going to do quite a bit of shop cleanup and we're going to have to move some of this stuff out of there. Now you'll see on the computer I'm using Mach 3, and I can't say more good things about that company. I mean, they've pretty much manufactured something that everyone out there in their dog can build something, and then they can hook this program to it. And it's super affordable for everybody. Now, I'm going to start the program there on the pendant, and then let's go through what's happening as it's happening, as it's happening here. And we're not going to get the exact perfect cuts today, and that's because of a few factors. But we'll get into that. So now we're doing a preheat cycle here, and we're just going to wait until on the top of the metal I can kind of see little beads starting to kind of crumble away, and then I'll just turn it on and hit start like I did there, and we're off to the races. Now, as I'm cutting here, I've got a couple of my pressures just a little bit wrong, and I've got my height a little bit out as well. And that's not that big of a deal, and I kind of rolled the dice on here, just hoping that it was going to cut through all the way. I could have stopped and changed my height, brought it up a little bit, and then changed my pressures a little bit, but I mean, things wouldn't be interesting if I did it the proper way the first time. And because of that, we're going to run into a small problem. It stopped cutting halfway through. Now, it's not that big of a deal, really. What I'm going to do is I'm just going to back up my G-code, fire this bad boy up again, and let it run around to where it was. And simply by hitting start or pause, I can pause it right where it stopped cutting, and then I can do my preheat cycle again, and then hit start, and then boom, you're pretty much off to the races, and you might have a small cleanup on one of the corners, but it's not too big of a deal. Now, let's get this all set up to cut the other 3 plates out, and then we'll let them cool just a little bit, have a quick coffee, and then we'll grab them and we'll take them out to the side shop and clean them up just a little bit and weld them up. So it's kind of difficult sometimes not getting swept away in the process of making stuff, and you got to juggle the YouTube kind of camera as well. And I didn't quite get the video of me placing it down on there, but I think you kind of get the idea of it. I'm going to place it down on those plates that we cut out, and then I'm going to attack it quickly on all 4 corners. Now, if you're new to welding, if you didn't know this already, if you were to weld this right tight on one side, when that weld cools, it's going to lift and buckle a little bit, and you're going to have some super huge gaps on the other side. Also, I wasn't quite sure what the paint was on this, so I made sure I had some good airflow going through the shop. And then I really started tacking down some welds and putting some good heat to it and making sure this was going to last for the time to come. And speaking of timing, you're probably wondering, how are these going to be bolted to the house? Well, that was kind of one of the mysteries that I had when I was building this as well. And I had to start building it while I was waiting for the information to come in on what size to drill bit to use. And by the time I was done welding that, I got the phone call and was told 1/2 inch was going to be perfect for it. So let's drill some 1/2 inch holes in here. But before I get to that, I got to be a little bit creative here and kind of figure out how to hold this in the milling machine. Now, because I welded on both sides, I didn't really have kind of an accurate way of holding it without ruining my vice jaws or it being kind of crooked. So I'm going to hold the very, very bottom of that plate. But before I do, I got to knock off some of the slag, kind of the little beads that kind of stick on there. and make sure that they're not going to interfere with holding it down. If I was to leave one of those little beads on there, it could wind up putting little dimples in my precision jaws, and that probably wouldn't be a very good day. Now, here's where I had to get kind of fun creative. I've got my clamp down kit, and I'm going to create a stop for this work so I can put this work in and have it stop in the exact same spot every time. Now, I didn't have to get fancy with anything. I basically just had to make it bolt down to the table, and then at the top, basically stop the work. Now, the key here is I did put the stop up to the work, but I have to take the work out and put it back in again. And if I don't do that, the first part is going to be possibly in a slightly different position than the other three parts later on down the road. There's some science and geometry and physics to it, but basically you got to trust me on this. You got to take that work out and put it back in and do that consistently for all four parts. So what I'm going to do here is zero this here now that I found the edge on the one side, bring it over to the other side, then we're going to do some simple math. Now, the paper technique here isn't exactly necessary, but I was being a little bit more overcautious. Because that's a brand new 1/2-inch drill bit, I want to keep it nice, at least for a little while, and not chew up the sides of it. And what I'm doing here is as soon as it starts kind of chipping away at a bit of the paper, I know I've got close to my side, and then I can stop feeding in. Now that we've got our number, we're just going to divide that by 2, and I'm going to draw the coordinates down on my chalk. So what I'm going to do here is I'm going to write the XY coordinates down on the vise. Now, this is important to me because it keeps those numbers visible while I'm drilling, kind of doing production work. I used to write it down on paper and then have it sitting beside me, or even that whiteboard you see off to my right. I used to write it down on that, but I kind of found that looking over to the opposite direction or having a piece of paper that could blow away or get wet with coolant didn't quite really work for me. And in the end, if I make any mistakes or want to change anything, I'm going to wash this all off later when I clean up the mill machine paint. In my humble opinion, I'm pretty sure the drill press is one of the most dangerous tools in the machine shop. Now, I mean, there's more deadly machines in the machine shop for sure, but this is the one where the most complacency happens. Say you didn't bolt something down and it does the helicopter spin of doom, or you reach in there with a gloved hand and try taking one of the chips away. So I guess my reminder for everyone here is to always kind of be on guard. Even the simple jobs can become complicated jobs if you're not paying attention. And if you haven't seen one of these tools before, it's a pretty darn thrifty little tool to have in the shop. Basically what this is doing is it's a knife and it's cutting off that razor sharp burr there and breaking our corners for us. Keep in mind these little tiny details on finishing stuff are super important when you're manufacturing parts. You see, people don't necessarily see or notice it. Subconsciously though, people do notice it, and it's the difference between them thinking your part is a great part or your part is a mediocre part.